Okay, the last wee bit of the podcast is just about current electricity and why do electrons flow. So you know already that current electricity is the flow of electrons. And if you see the wee girl here again, she's standing on, touching the Van de Graaff, and she's standing on a piece of insulated material so that the charge doesn't pass through her. But if she wasn't standing on that, and she was standing just on the earth, that's an earth symbol there, then the charge would just flow through her down to the ground, and she would certainly know that. Her hair wouldn't stand up because she wouldn't be storing any static charge, and the current would just be passing through her. And that's just the flow of electrons to the earth. So in an ordinary circuit, that's exactly what happens. What you have to have is a source of energy, and in that source of energy you have two different potentials, a positive potential and a negative potential, or a positive voltage and a negative voltage. So of course you know that this is a battery symbol here. And provided that there's charge in this, or it's fully charged, then the current is going to flow from plus to minus whenever the switch is closed. The lamp will light up, the ammeter will register a current. It's exactly the same as a little girl. If she touches that and she's connected to the earth, there's a difference in potential. And then charge is going to flow, or electrons are going to flow through her down to the earth, and she'll certainly feel it. And that's why electrons flow. So electrons flow as a result of a voltage, or we call it a potential difference. Now that word should remind you of something like potential, gravitational potential energy. And do you know that things flow down a hill because water flows down a hill because at the top it's got gravitational potential energy. So this is very, very similar. Provided that there's a potential difference between the two ends of the battery, then current is going to flow around the circuit. Now in actual fact, the electrons in a circuit actually move from minus, they repel from the minus round to positive. But years ago, when scientists first came up with the idea of electricity, they didn't know it was electrons flowing. They thought it was positive particles. So they came up with the convention that electricity flows from plus to minus in a battery. It actually flows, electrons flow the other way around. But in terms of an exam, you should always mark on. If they ask you to mark on current flow, you go from plus to minus, and that's the direction of conventional current. If you're asked to mark on electron flow, electrons move the other direction, and that's actually the proper direction of current flow. But whenever you're asked to mark in current in a diagram, it's always from plus to minus. So the next thing we're going to do is define voltage. So you know that your battery has got voltage, 1.5 volts, most normal batteries have, but voltage is defined as the energy transferred to other forms per coulomb of charge passing around a circuit. And of course, as this is physics, we shorten that to an equation. And our equation is energy is equal to charge times voltage. Or if I rearrange that, voltage is energy over charge. So that's very similar to what we said there. Energy transferred to other forms per coulomb of charge that passes around a circuit. And of course, those other forms would be, if you had a bulb, then energy would be changed from electrical energy or chemical energy, depending what's powering the bulb, from electrical energy into light energy and heat energy. If you had an electric motor, you would have that energy being transferred to kinetic energy. So this is our equation. E is equal to QV. We normally remember it like this. E is equal to QV. E stands for energy, Q for charge, and V for voltage. Energy is measured in joules, charge is measured in coulombs, and voltage is measured in volts. So here's a question. You have a charge of 100 coulombs. So as usual, just write down all the things that you have. I see you can't see that, so I'll just put it down a little bit. So you've got a charge of 100 coulombs, so Q is the symbol for charge. A potential difference, so another word for potential difference is voltage. So you've got a voltage. Even if you weren't sure about that, you can see the unit gives it away there, 5 volts. And we're looking for how much energy. So E is equal to QV, so write your equation down first. That's 100 coulombs times 5 volts, and the answer is 500, and the unit for energy is of course joules.